All right, let's finish up the graphing portion with part D. So if you weren't listening when I told you to change this one, just so you're aware, this is our B value, correct? This 0.5, but our B always has to be factored out. So instead of having the B multiplied through, it has to be factored out. So if I were to factor this out, it would be pi over, not pi over 4, pi over 2, right? 2 times 2 would be 4. Now, I would not give you one like this. I'm not trying to trick you this much at all. So if you want to just disregard this equation and work with the equation above, feel free to ignore my reasoning, but essentially the idea behind this is our B has to be factored out. It has to be outside the parenthesis. That's how our equation goes. So if you were just looking at this equation, you would think it's shifting pi over 4 to the right, but actually it's shifting pi over 2 to the right. So that's why you always have to factor out your B, although I would not do that to you on the final. But there's the idea behind that one. So working with this one now, it looks like my amplitude is 1/2. It looks like my B is 1/2. So that means my period is going to be 4 pi. My shifts, as I just said, are going to be right pi over 2 and up 2. Up 2, and my domain for sine and cosine is always all reals, and my range, let's think, typically my range is from -1 to 1. Since my amplitude is 1/2, it becomes -1/2 to 1/2, and then adding 2 to each of those endpoints, it looks like my range is going to be 1.5 to 2.5. Oops, I need a bracket there. Awesome. So again, when we're graphing, some of you like to reassign your axes, some of you don't. I'm on the videos, I'm reassigning, but in my binder, I did not. So I have 2 different methods to show you. This is one in the video. If you'd like to see the other one, check out my binder, talk to me, and I'll let you know if you're on the right track. But just for sake of space, right, if I reassign my axes, it makes my graph bigger. So just for you to be able to see it better. So 1.5, 2.5, that would mean that my center here is going to be 2, which is great. Let's get graphing then. So we're shifting right pi over 2. So that means my start point is going to be pi over 2. Right? So now to figure out what my subintervals are, I need to do the trick here. I'm just trying to find good space. I'm running out of space. Okay, why don't we we'll come down here. So 0, 1/4, 1/2, 3/4, and 1, right? Those are my subintervals. So you multiply that by the period, and then I'm shifting right pi over 2, correct? So this becomes, my first subinterval is 0 times 4 pi. That's just 0. 0 plus pi over 2 is pi over 2, right? Awesome. Okay, 1/4 times 4 pi plus pi over 2 is my second subinterval. 1/4 times 4 pi is pi. Pi plus pi over 2. If I want to get some common denominator, that is going to be 3 pi over 2. 1/2 times 4 pi plus pi over 2. That's going to be 2 pi plus pi over 2. So common denominator makes this 5 pi over 2. Now you can keep going with this, but Maybe some of you are starting to see the pattern. 1, 3, 5, 7, 9. Okay. So those are my subintervals. It is a sine graph, so I'm going to start in the middle. Sine soars, so it goes up first, then down, and I'm getting into my subintervals there, but that's okay. And there is my sine graph. And as a reminder, it keeps going. I just ask that you graph one period, but just as a reminder, it will keep going. Beautiful. Next one here is going from a graph to an equation. So a lot of people, when they see sinusoidal, it's hard to say, equation, think, oh, I have to use a sine equation. That's not true. The sinusoidal equation, that's a general name for graphs that look like this. Okay, well, graphs that look like this can be a sine or a cosine, right? So I see a cosine right here. This is a flipped cosine. I see a sine starting about right here in green. So there's sines and cosines in this graph. So it's just depending on what you prefer. What do you want to graph? What do you want your equation to be? Do you want it to be a sine? Do you want it to be cosine? I would recommend looking and figuring out what's going to be the easiest. So let's start by finding my amplitude. So to find my amplitude, I need to find my midline. So it looks like this is -1. This is going to be 1 then. This is going to be 3. So it's going from -1 to 3. So 3 minus -1 is 4. 4 divided by 2 is 2. My amplitude is 2. So my midline here is 1. Right? And the distance between 1 and 3 is 2. My next step is to solve for my b. So I would need to figure out what my period is. So let's look at this cosine graph. That's our easiest one to figure out. It looks like the period is pi. So 2 pi divided by b equals pi. So then b would equal 2, right? 2 pi divided by 2 is pi. All right, and then what about my k? What about my vertical shift? Usually my midline is at 0. Now it's shifting up 1. So my k is a +1. So I'm going to show you both a cosine and a sine graph. So for cosine, it's going to be y equal, my amplitude is 2, but wait, this cosine is flipped, correct? It starts down, so I need a negative out front. Cosine of 2x, because b is 2, plus 1. So a sine graph then, let's outline it. It's going to be this one in red. Here's a sine. So I need to figure out, where does that start? Well, it's going to be in between 0 and pi over 2. Pi over 2 divided by 2, that's pi over 4. So, sine y equals 2, I don't need that negative. Sine, b is always factored out if there's a shift. I'm shifting to the right, so it's minus pi over 4 plus 1. Since I've done this problem with a lot of you, I do know that a lot of us picked this cosine graph. So I'll give you the equation for that one as well. It's going to be 2 cosine 2x minus pi over 2 plus 1. Now, on the test, I probably will not require you to write 3 options, but for now I'm just showing you, right, as much as I can, so that hopefully one of these, you're like, oh yeah, that's the one that I did. That's the one that makes the most sense to me. So notice in all of my equations, my amplitude is the same, my b value is the same, and my k, my vertical shift, is always the same. So really the only thing that should differ from equation to equation is your horizontal shift or lack thereof, right? In this one I didn't have any horizontal shift. Also what might be different is the reflection, right? In that blue equation there. Great. Let's move on to my favorite topic. And no one agrees with me. Wait, some of you do. Some of you like these, and maybe more of you do. You just don't want to admit it. This is the unit where we verified identities. So just as a reminder, you have an equation. So I'm telling you the left side should equal the right side. And you just have to use identities, algebra, in combination to get one side to look like the other. Now, you do not have to start with the left side. Typically, it's the way you the problems are set up, but not always, so don't rely on that. In this case, obviously, there's not a whole lot going on that right side. So I'm going to start on the left side. And I have two fractions being added together. So right away, you should think common denominator. So let's think here. My common denominator is going to be cosine times 1 plus sine, right? So we have to multiply the other fraction by what it's missing. So top and bottom by 1 plus sine, and top and bottom by cosine over here. So that gives me cosine times cosine, that's cosine squared, and then plus 1 plus sine x squared. Now, a lot of people wanted to just not have to FOIL this out, but we do have to. So I'm just going to go over here and multiply this out. So 1 times 1 gives me 1. Sine times 1 gives me sine. Sine times 1 gives me sine. Plus sine squared. So I get sine squared plus 2 sine plus 1. Awesome. So let's rewrite this. I get cosine squared plus sine squared plus 2 sine plus 1, right? All over cosine times 1 plus sine. All right, hopefully we remember cosine squared plus sine squared is just equal to 1. So I get 1 plus 1, which will give me 2 plus 2 sine of x, all over cosine 1 plus sine. And then from here, so this step, this is just my work over here. Just trying to organize. And then after this, I can think, okay, I got it down, but I want it to just be, I want a 1 over cosine, right? Because that's what secant is. So that's 1 over cosine. So I want these sines out of here. So let's think, how am I going to cancel that out? Well, let's try to see if something factors out from the numerator. It sure does, right? The numerator has 2 and 2. So I can factor out a 2, and I get 1 plus sine all over cosine 1 plus sine, right? So this cancels, and I get 2 over cosine, aka 2 secant. Done. Remember, we need multiplication to cancel. Awesome.